Yeah. I think it's okay. Shut that mic. Hi, Matt. Morning. How are you? Okay, I think you're going to make a start. Welcome to NVO3. I'm Matthew Bocci, and my co-chair Sam unfortunately couldn't make it this time, so please go easy on me if there's any technical glitches. Our secretary, as you, will be doing the minutes. Thank you. Here is the note. Well, it basically says any statements you make here are a contribution to the IETF. I'm sure you're well aware of this now, but just take a minute to contemplate the note well, please. Okay, it's administrivia. So the blue sheets are going down each side of the room. If they reach the back, please could you pass them back again forwards to catch anybody that came in after they went past. Okay, agenda. We have one last-minute addition to the agenda compared with the one that we published a few days ago. So Mina's going to do an update on or present a draft on BFD for Genève that was already presented in the BFD meeting yesterday. Asked him to come along and present it here. Any comments on the agenda? So our milestones, so we did update them, and as usual, they're out of date already. So the chairs will go in and post an update to the list for your review on these. Of course, these are incorrect anyway, because it states that we should have rechartered or closed the working group back in August last year. Right, document status. So we have no new RFCs since the last IETF or the previous IETF. We have a few RFCs published though, in general. Our data pane encapsulation document, which is draft IETF NVO3 Genève. This is on the agenda. It went through working group last call. There was some discussion after the working group last call around that. You may have seen on the list. And we have an update on where we are with Genève in this meeting. The output of the design team encapsulation, the design team for the encapsulation choice has currently expired. Our intention was to publish that, or do a publication request for that in order to document the encapsulation choice process and rationale after we had sent Genève to the IESG. We still intend to do that, but ideally we'd obviously like to see this document revived first, since we can't last call an expired draft. So if you are an author of this draft, please can you wake it up? We are currently going through a working group last call for the EVPN applicability to Geneva draft. This corresponds to some work that was also done in the BEST working group for signaling the parameters related to the Geneva encapsulation in EVPN and BGP. There hasn't been a lot of response on the list to this, so can you raise your hand if you have read this document, please? Okay, 1, 2, good, 3. Raises a co-author. Could you please ideally read the document? This is a fairly significant piece of our control plane work in NVO3, because obviously we can't proceed if there's no real response on the list to the working group last call. And please send comments to the list. Or if you have no comments, just say you're okay with it. But to respond positively or negatively or otherwise send comments. That would be much appreciated, thank you. We did also go through a working group adoption poll for the security requirements. These are on the agenda. There was quite a few comments and quite a bit of discussion around that as well, and Daniel's going to give us an update on where we are with that draft. There's a virtual machine mobility protocol document. So we tried to do a working group last call on that. It's currently expired. We haven't had a lot of response or discussion or review on the list again. We did request some ops area, routing directorate and TSV area reviews, and we've had a number of comments from those reviews, but the authors have gone rather quiet on this document after pushing quite hard for it to be last called. So we would appreciate some activity from the authors or the editors. We will be chasing them to try and revive this. Otherwise, I think we're probably going to have to park it. So unfortunately, we can't, or we need to find a new editor. So we'll probably do either a consensus call on the list to find out if the working group is still interested in this work. Right, on to the session presentations. So, first up is Daniel with the security requirements.
Hi. So I'm going to present So I'm going to go through the Geneva security requirement draft, status, and issues that I think it has to be solved to make that document move forward. So the history is we had a call for adoption in February. We had an update in November, in March. So in March, we received some comments and reviews from the person from the security directorate that reviewed the Geneva specification, provide comments. I think we address those comments, which means we clarify, and also from the feedback we received in Bangkok. So we had a split between the requirements we think are operational and the requirement for Geneva mechanisms, generate mechanism for security. We also uniformized the requirement for authentication and encryption, so there is a clear parallel between those. And we also had a deeper analysis with how and when you can use IPsec or DTLS in specific deployments, and what is actually missing to have the IPsec and DTLS in every deployment. So we went through, for each of these solutions, we went through all the different requirements, and I think it's in an annex section, but I think it's a good way for people willing to use those mechanisms to know where's the corner cases. So what is this security requirement draft on? It provides requirements, but those requirements are mostly based on the threat model and the specification of the Genève protocol. So these are the two inputs, and from the two inputs, we issue some requirements. So if you disagree with some of the requirements, usually we have to see, the origin of the contention, which might be the threat model, for example, or the specification, or the understanding of the specification. So requirements, as I mentioned before, are operational, which means it's a kind of checklist to operational people could check to see if their deployment is actually securely deployed, or it's a protocol which is a checklist for next to be Genève security mechanisms, if ever such mechanism has to be defined. So the security requirements, as mentioned before, are closely tightened to the Genève specification. And today's that's version 12. We believe it reveals some incoherence to the Genève specifications, or at least some misunderstanding from our part. And currently it's being stalled for many months. And we're just waiting for this clarification in the protocol to move that forward. So Genève and DTLS. So we received before Bangkok some comments from the Genève co-author, and we addressed those. And since then, we didn't have the necessary follow-up to claim or have the confirmation that we have addressed their concern. So we're trying to, based on their feedbacks, we're trying to figure out where the problem is. But it would be good we could have that dialogue. So my understanding of feedback we received from the co-author is that the use case, the use of DTLS is sufficient to secure Genève deployments. And the other one is that security capabilities for the transit device, so what the transit device is going to read does not need to be secure, or it's not necessary. So in my opinion, and I'm happy to be wrong, but DTLS and IPsec cannot be secure for a generic Genève overlay. It cannot be the generic mechanisms we provide associated to Genève. And the other thing is that NVE and transit device are reading Genève options and are processing those options. So there is no reason to have one being secure, the other one not being secure. This transit device there is clearly communications between NVE, and transit device, which is some sort of three-party communications, because they all share some Genève options. And this is a very hard thing to do, at least securely. So one of the concerns is that, well, the security complexity over Genève, I agree it might be complex to have the three-party, but it's probably reflect the consequence of a complex architecture overall. And that's more my understanding. So just to be clear, why DTLS or IPsec cannot be used as a generic security mechanism for Genève. This is an example of a deployment. And I think I hope, my understanding is that it's compatible with the current spec. So you have Genève option here, A, B, C, processed by one NVE. And on this side, you have the transit device processing options, reading and processing option B, C. And this one, NVE, is processing option A. So the packet goes for example, through this NVE, it goes to the transit device. So it has A, B, C. B, C are being processed here, and here you have option A. Is that, I mean, is there anything wrong with that deployment, for example? Any big misunderstanding of the specification? If there is, I mean, please raise it on the mailing list. I'm more happy to understand that. But if that's appropriate, or then suppose you use DTLS. Well, the thing is that, so I split the Geneve header between a fixed header and the options. So you use DTLS here. So this NVE is able to process A, B, C, D. But the transit device, you're using DTLS. So basically, all of this is going to be encrypted. So transit device is bypassing the encrypted traffic. There is no way you can process BCD. And this one, the latest one, can have access to A, B, C, D. It can process A, but it has almost no clue that the transit devices has or not processed BCD. Or at least it has, I mean, it's. So, in this case, well, only option A is being processed at the end, and there is no signaling, nothing, so that the receiving NVE can actually detect that it's only one of the 4 options that has been processed. So if you were using security option that says, well, this is a security option would be a marker saying from that point it's going to be secure. So if you had this capability, then you could have security at the Geneve level, which means option N, B, C, D. So you say, well, option B, C, D are going to be performed by the transit device. I'm securing up to that layer. So you have option B, C, D. And up to that layer, it's being secure. Transit device can't look at it. And here, well, the encryption, option A can be processed. So this transit device, if we want to have those, we clearly need to have the security being performed at the Geneve layer. It doesn't mean we always have. If you remove the transit device, you can use DTLS. Perfect. But it cannot be considered as the generic security mechanism. So the problem is really that the transit device prevents end-to-end security to be performed. The counter argument is that the transit devices are optional. This is not really true because, well, first of all, we haven't seen any mechanisms where transit device or transit nodes are mandatory. So the fact that it is optional in capital letter is even suspicious. It's a bit like when your banker say it's free, you say, oh. Or when your kids come back from school and say, I've been very quiet. It's, what have you done? It's not, oh, it's good. I trust you. So the problem is that it's not optional. Transit devices are not optional in the sense of this RFC specification, the meaning of this term, because if you introduce those devices, it's going to affect your deployment. So it's more, the deployment has to be made in function of this transit device, at least the security part, which contradicts, in my understanding, the term optional. So if we want to have Geneve as an end-to-end protocol, it's much easier to secure end-to-end protocol. This can be easily done at the IETF. reusing existing protocols. But the thing is that we need to have the protocol being end-to-end. If you want to use end-to-end security, the protocol has to be end-to-end, which is not achieved with transit device. So I think it's a good path to go to end-to-end end-to-end protocol. Security much easier. The threat model is easier to understand. It's going to be security analysis is going to be much clearer. Requirements, less requirements. Well, I think it's a good path. The question is then, do we need those transit devices? So I haven't seen...
Daniel, can you go back quicker, please?
Yeah, so I haven't seen any use case for these transit devices. So I'm asking that to the mailing list, so if you have any, please go through the...
Daniel, there was just a little bit of history on the transit devices. There was a lot of discussion in the working group a number of years ago about things like being able to trace the underlay from the overlay. So that means that the transit, what you call a transit device, a router or a switcher along the path of, or a router along the path of the NVO3 along the path of the tunnel, must be able to actually inspect, for example, OEM messages must be alerted and be able to inspect and then respond to OEM. So that's one example of a transit device. So if you look back on the list, and there were actually drafts in the working group. Transcending trace routes was one of them. Now, whether or not you call that a transit device, I don't know. But architecturally, the problem is that in the framework, we don't have transit devices formally defined in the NVO3 framework.
David Black, is there a need for the transit device to insert, remove, or modify options, or is the POS requirement merely that certain options be visible to the transit device, but not be modifiable en route?
So I think that the current spec is only read.
If the current spec is only read, then with a little bit more design work, unfortunately DTLS is not exactly what you want. You can arrange to secure the readable options for integrity end-to-end without encrypting them, and then encrypt everything else. And at that point, you're back to an end-to-end security model. Just some of the stuff that you have integrity protected end-to-end is in the clear.
Yeah, I think that's something that can be done if we need these transit devices. So that's and we can also agree to have whatever is being read by the transit device protected or not, but that's need to be clearly stated and discussed.
Elango, I think you were next to me too.
Yes. So first thing, I think you are not characterize the transit devices accurately, and that's the main contention between what you have written in the document, Daniel, versus what the architecture supports in Geneva. Transit devices exist in the network, right? So it's it could be the switches or routers, whatever that carries or forwards the traffic between the two endpoints, right? And what we are allowing is we have a formal guidelines so that you're exposing, or when the transit devices are viewing the headers information, Geneva header information, they can use that information. For example, I gave you a very specific example, like could be ECMP purposes. There could be an option that has, for example, flow context. So it might be using the transit device might be using the flow context in order to forward the traffic, right? For ECMP purposes. If if Geneva is secured end-to-end between the NVEs, then it doesn't have the visibility, and if it doesn't have the visibility, it can continue to forward it based upon the outer header information. And today, that's how the transit devices today operate, irrespective of Geneva. Even with other encapsulation protocol, that's how it operates. And it does not, require that Geneva does not require the transit devices has to look at or observe the options in order to forward the traffic. That's number one, right? And encryption, this is if you are using encryption. If you're not using encryption, and as I think David Black said, if you're using data integrity mechanism, then you don't have to do that, right? So different deployments may choose to expose this information to the transit device or not, depending upon what's applicable to that deployment. It doesn't mean that Geneve is not secure, or it doesn't mean that Geneve is not, secure end-to-end. So I would suggest that the author, does not mischaracterize that Geneve is insecure just because, you want to we are exposing that to the transit devices. Even if you remove the transit devices, nothing precludes the transit devices from viewing the data.
David Blacken, I don't think I heard a suggestion that it was insecure. What I think I heard was a suggestion that if you want transit devices, you need to do something Geneve specific. And I think what I heard from Alongo was mostly in terms of exposure, not modification, which is going to make the problem much, much simpler. I also think back to the router sort of tutorial discussion yesterday afternoon, and I would suggest that in searching or removing options en route is going to be painful for some of that high-speed hardware, and that's clearly to be avoided. Modification would be bad enough. And it sounds like we don't even need to do that, which means that you've probably got an end-to-end security model. You just have to figure out how to spec the crypto to get integrity on the stuff that needs to be exposed to the transit devices. All right, Alongo, I must have said something.
You said it correctly, David. The transit devices can view the data. It cannot modify or it cannot insert the options. The options can be inserted, or in general, the Geneve header is inserted and removed by the endpoints, not by the transit devices.
Tom Herbert. So along that point, that last point, ports are not reserved. That effectively means that transit devices cannot modify UDP payload. It's problematic because they don't know if this is actually Geneve. This could be used for anything. So this should be a must not modify in flight, as far as I'm concerned.
Yeah.
Greg Muskiziti.
So just a minute, just let I go respond to that. Oh, no.
We have spec in the document saying that it must not modify.
Sorry, could you repeat that? I think I cut you off by mistake.
Herbert said, right, it's accurate that the specification clearly says that the transit devices must not modify the Geneve headers.
Correct.
Okay, I think that I understood comment differently. It was not saying that says, it should say. But my comment was continue what they said in connection to yesterday, Bob, is there was a suggestion to start data plane consideration, especially for new encapsulations and variable length encapsulations. I think that will be good to take it before it becomes mandatory and add a section that will highlight impact of Geneve on a fast path processing.
So if I'm trying to summarize some of the comments, the current spec is saying clearly that, I think that was my reading, that transit device can only read. But the current spec does not make any, I mean, the recommendation on how to protect the Geneve packets does not apply with those even read-only, because you don't provide any security mechanisms, nor for this transit device. So if you use the transit device, what I'm trying to say is that following the current recommendation for security mechanisms, you cannot deploy transit device in a secure way. That's what yeah. So we need to have that done.
Daniel, can you wrap up now?
Yeah, so I'm wrapping up. So, but the thing is that the transit device are really, I think more characterization is needed on the transit device, so that to clarify this, because they appear clearly like middle boxes, so which needs explicit signalings. This has been debated, and I think it would be useful to be done here. Transit devices are somehow hardly compatible with UDP encapsulation, because how a transit device will detect it's a Geneva packet.
Daniel, can you skip to the summary? Sorry,
Yeah.
I'll take it to this because we're really
Okay.
we're out of time.
So, conclusion. The transit device introduced a lot of complexity currently, so maybe we have to reduce that. And it is not addressed yet by the current specifications. Security complexity, it's not enough to say security is complex. Usually the security reflects the complexity underlying. So, and we should have more use cases on those transit devices to understand what is the intention. So the next step I would like is that we enabled some discussions regarding these security requirements. So that the first step for that would be the adoption of the document. Removal of the transit device from the specification is just one way, but it's maybe not what the working group is willing, but we have to discuss that, how to integrate then properly, but this is not currently, in my opinion, done. So I might be wrong, but I'm stating my vision. And so, well, the security analysis needs also some work. So we need to understand what are the requirements from the Geneva, from the NVO3 and so on to update this security analysis.
Okay.
I mean, it's not hardline.
Okay,
And that's all.
thank you.
Thank you for
Thanks,
your time.
Daniel. And there you go, you're...
And
Right.
feel free to be active on the mailing list. I'm happy to any feedback.
Are you able to hear me?
Yes, thanks.
Yes. So I'll provide an update on the Geneva working group last call. So let's move to the next slide. Yeah, I would also like to acknowledge the other co-authors and co-editors, T. Sridhar and Jesse Gross, who worked during this process, working group last call process, and right from the beginning. So draft Geneva was updated to address the working group last call comments, and as well as we had TS-VRT early review and SecDAR early review. And we have the latest draft that's posted, which is IETF NVO3 13. Between the 12 and 13, there's only one change that I posted that on the mailing list as well. So we address all the comments to the satisfaction of the commenters, except for the two comments as noted below. One of them is from Daniel Migault. This is the comment regarding options handling. We have updated the text to restate the requirement on options processing so that to provide better clarity. It still maintains the original intent. And the other comment is about the transit devices. I think we tried to explain multiple times on how the transit devices work. And we have provided sufficient clarification on the behavior of the devices. And we believe there are no issues with the definition of transit devices. And moving on to the next slide. And on TS-VRT early review, we added applicability statement and reference to UDP usage guidelines as per RFC 8085. And we updated the text to address data integrity and checksum usage guidelines for IPv4 and IPv6. And we also added text on usage of Geneva in traffic managed control environment as outlined in RFC 8086. We also added text on guidelines to minimize or address IP fragmentation issues. And I would like to acknowledge David Black for providing us detailed comment and working with us in improving the document to address the comments on the TS-VRT early review. And the SecDAR early review, we also updated the text on options interpretation by transit devices. And we also added clarifying text to security consideration section. Again, related transit devices and as well as other general area. And we also clarified reserved bit handling. And we would also like to acknowledge Magnus Nystrom in providing a review and helping us improve the document. Moving on to the next slide. And in general, these are the working group last call comments. We have several commenters who submitted comments on the working group last call, and we have addressed all those comments, and we did post them on the mailing list and to the satisfaction of the commenters. So we, just to give you a summary, that we added or modified clarity on the options processing and checking, and we also provided interpretation on options by the transit devices, and we also clarified by providing text on the role of transit devices, and we updated the security consideration section. In general, we added text. We beefed up the transit security consideration sections a lot for clarity, as well as we removed redundant text for better readability purposes. And we also addressed few editorial comments. Moving on to the next slide. And there are a few other comments. One of them is updated the guidance on the TTL handling. This is mainly to provide reference to RFC 2003 to provide guidance on this model. And we also provided informative reference to RFC 8293, that is the multicast handling for the encapsulation overlays. And we also clarified the O-bit usage that is used to indicate control messages between NVEs. And we updated reference to IANA section to a newer reference, which is RFC 8126. And we also provided option class assignment. We clarified that we have a range of IETF review, and we also have a range with a lenient policy, which is first come first served. Moving on to the next slide. And we have addressed all those comments, and then we also updated the latest change, which I mentioned and as published as Geneve version 13. And we believe that the draft is ready for IESG review. Thank you.
David.
David Black, as Transport Area Reviewer. First of all, I want to thank Elango and authors for doing a very productive and cooperative job of addressing what could have been some rather difficult comments on the draft. There are a couple of issues that, borrowing from Transport Area lingo, I would characterize as half open, where the proverbial right thing to do, in quotes, does not seem to align well with running code. And I want to quickly bring these to the working group's attention. I expect they'll get more attention during IETF last call. The first one is that omitting UDP checksums in IPv6 is an interesting area. If you zero out the UDP checksum, you want to increase the hamming distance between valid packets to as much as you can. One of the recommended techniques for doing so is to vary the IPv6 source address. Not clear that this is what running code is prepared to do. And the other one is that it's a very good idea for an encapsulating NVE to maintain an MTU value for the tunnel, particularly when that encapsulating NVE is not at the traffic origination point. The upshot is that if you send a packet into that NVE from the network and it's too large, you get the ICMP response from the encapsulating node rather than getting it downstream somewhere and risking losing ICMP payload. Both of these, I think, wound up as maze because I think Elango are resigned to the fact that while they're good things to do, running code's not doing them.
Thank you. And we have also noted that as an editorial note so that the working group members can review that those 2 points. Thank you.
Okay. Any other comments? Okay. So I think the chairs and the AD will probably discuss how to proceed with this because we still have this ongoing security comments coming from Daniel. I mean, he is the only person who still has concerns on the list. It has to be said. So, but they may be valid, and we have to be aware of that those may be brought up again in the security directorate review by the security ADs if we progress. But anyway, we'll get together with the authors and decide how to proceed. But I think as far as we can see from the perspective of calling consensus from the list discussion, I think we're probably pretty much there, but there's still some discussion around security that we have to be aware of. So I can address that as a part of the Shepherd's review. Okay. Go ahead.
Yes, hi. I see the co-op. Yeah, I just wanted to highlight the help from multiple folks, as Elango said, on making this a better draft. And also, we believe the version 13 addresses the comments for the security, considerations as well, and clarifies the text. We believe it's a little more crisp with respect to the role of transit devices. Just wanted to state that as a comment.
Okay, thank you. Okay, thanks, Elango.
Thank you.
So next we have Xavier for the 5G data center interconnection use cases. Hi.
Hi. So this presentation will be on 5G data center as a interconnection as a use case. All right. Thank you. So this is a presentation on the 5G data center interconnection as a use case. And I'm Xavier Defroy, presenting on behalf of my co-author, Ulysses. So what are we trying to do here? We are trying to extend edge or cloud data centers to include 5G devices. And computing mobility is a driver, as in edge computing mobility. Common use cases you will find in cloudlets or other, similar projects are offloading VMs, from a device to a server, or the opposite. And we just propose to look at it from the 5G standpoint, where you offload a VM from a 5G device to a data center server, for example, to save battery, or you can transfer a VM from a data center server to a 5G device. And there you can reduce latency, or you can increase the autonomy of a component. Use cases could include industrial IoT, V2X, or fog applications. And so we think that a certain type of 5G data center integration could enable transparent mobility of VMs between 5G devices and data center servers. That can simplify the design of distributed applications by, effectively extending the edge data centers. So a goal of this would be to describe a new use case for data center protocols, where the operator of a data center network would use 5G devices in a way very similar to, data center servers. So there, for example, the NVE could be either internal to the 5G device where the hypervisor is, or, it could be external. It could be at the edge of the 5G system. So our goal, with this draft was to reach out here to the community here. So we needed to choose an option as a first example. So in our initial draft, we selected this last option. And so we did that because 5G LAN, which is a new feature in 5G, and it enables LAN connectivity. So it probably does most or a lot of what needs to be done on the 5G side. Right, so it provides IP or Ethernet LAN connectivity between a 5G device and another 5G device, or another LAN device. And so compared to an internal NVE solution, the interest of this, maybe the best interest, is basically that it enables a more efficient usage of the air interface, because you don't need to carry the GNV headers, for example, over the air. And also it leverages other 5G features. So you have authentication, session continuity, or fine-grained QoS, for example. So here is a, just as an illustration of the possible type of interconnections you could have. You have NVO3 domain in the center and 5G system represented on the side. So first type of interconnection would be between the control plane. Here, the control plane of a 5G LAN would be session management function, including the management of a 5G LAN group. And on the other side, you would have an NVA. And in between, you can have either it can be some form of cooperation configuration, or you can go through some network functions. But, you know, this is not a 5G type of use case we have here, so we don't want necessarily to go into any details there, but just to have an idea of what type of requirements we would have on that type of cooperation. And then you would have also a second type of interface between the network anchor in the 5G on the 5G side, so that the UPF here, and an NVE on the NVO3 side, or some form of gateway. And so you would have data plane packets going through there, and possibly control packets as well, control messages. Now, in terms of features of this interconnection, the core one would be layer 2 or layer 3 connectivity between VMs on the device and VMs on the servers. Hot VM migration support would be an important feature as well. And since those are 5G devices, you may want also to support some form of mobility. So if multiple UPFs are connected to the same edge data center or multiple data centers which are interconnected, you may need to support a UE moving, relocating from one UPF to the other. And other features in this interconnection could include a QoS or access control. So basically, we are looking really for a community willing to discuss this. We'd like to know basically if there is some form of interest. Do you think an NVO3 data center would benefit from including or extending virtual networks towards 5G devices? Is this the right? This is the last slide. So is this the right forum for it? Do you think that there is interest in this room or in this area to basically discuss at very high level what could be some form of cooperation between a data center and 5G? So thank you for your interest.
I think it is a very interesting usage scenario, because I think in this room, most of the people are talking about DCN, and you are talking about interconnection of DCs. So in your opinion, is there any usage scenarios which permits us to define, for example, some TLVs for Geneva or not?
Really, at this point, I don't really know of any impact on NVO3. That's very high level, so I'm not sure. Maybe.
Yeah, I mean, it may be a good thing, because people are not very clear about the definition of TLVs, how to use, what can they do with TLVs. Maybe if we find some interesting scenarios, we can define some TLVs for Geneva, which I think it will be helpful to extend the usage scope of Geneva.
Thank you. I mean, that's one of the really goals of coming here, is to find people interested in the community who would like to bring some expertise in data centers and see if they are interested or not, and what exactly, that type of things. Thank you.
Greg Merzgiziti. So because in 5G, we learned that they're considering three silos, three use cases. It's ultra-reliable low latency, extended mobile broadband, and extensive machine-to-machine communication. Do you see that for all these three scenarios, one solution will be suitable?
Actually, I hope that not. I think that you have a lot of work being done in the 5G to support edge computing, as you know, probably. And there is lately there was a new study starting to enhance the support for edge computing. So I think that right now in 5G does not really mandate any specific thing outside of 5G in terms of data centers, etc. It provides some mechanism to enable interconnection with external data networks. So personally, I don't think that there is one solution that will be
Okay.
mandatory.
On a little bit different angle. So where would you suggest to look for requirements for these use cases for scenarios? So because I think that ultra reliable low latency, especially since you mentioned multi-access edge computing to minimize round trip delay. So probably might have some distinct set of requirements comparing to enhanced mobile broadband. So would you suggest any source of requirements?
Actually, I think you may have an answer. Somebody will want to answer behind you.
Okay.
Ulises Olvera, Intelligent. Assuming that I understood your question, I think that one of the reasons why we thought it was interesting to bring this paper here and have the feedback from the community is that we're also looking at the 5G LAN feature that is currently being developed in 3GPP. And there, based on the requirements that I've seen there, IETF SA2 standards, this last case of the reliable communication, in particular, the use of 5G LAN-like type systems for industrial IoT. I think that would be the use case that, from my perspective, would be the most use for this type of 5G LAN cases. So that would be my input to your question.
Thank you.
Okay.
I want to bring your attention. Can you go back to a few slides to show the structure there? Yeah, this is a little bit like what we have already done in NVO3 working group called the split MAE or whatever, external MAE. So the difference is that your MAE, which is external device from the end device, and currently, because we are more focusing on the wired part, so there is a VLAN mapping between the so-called VNI and the VLAN. I probably want to consider for the for the 5G LAN case, what kind of mapping information, because between the PDU session there, you don't have the VNI information which is provided by Geneva. So that's one possibility. That's how NVO3 can help in your scenario.
Thank you. Maybe we can talk shortly after.
Yeah,
Thank
okay.
you.
I think we need to wrap up. Okay.
Thank you.
Thanks. Who's read this draft, actually? For those who've read the draft, who thinks this is in scope of NVO3, first of all, and there's some contribution NVO3 can make here? Because our charter is very much focused around kind of traditional fixed data centers in one geographical site, not the data center interconnect, but they, inside of a physical data center, and a distributed data center architecture like this is perhaps a little bit new. Okay, thank you.
Just would you advise on whether we should continue this work here right now, or should we speak later?
So what I'd do is I'd suggest that we need to get some more feedback on the list, get some more people first to read the draft. I think on the kind of scoping issue and charter issue, we'll talk with RID about that. Okay.
Thank you.
Thank you. All right. This one. Right.
Okay, morning everyone. I'm Remy from Huawei. So today I'll be presenting the base YANG data model for NVO3 protocols. So firstly, I would like to explain the motivation of this draft. So why we need it. When we look at the network virtualization overlay standards in IETF, we can see that the data plane, we already have multiple encapsulations in the data plane. For example, VXLAN, NVGRE, MPLS over UDP, and Geneva, which is in last call. And we also have standards in the control plane. For example, the EVPN for network virtualization, which is RFC 8365. And we also have a separate draft about the EVPN for Geneva. And obviously, the YANG model for overlay protocols is still missing, but it is very important for network configuration. And I understand that the NVO3 working group has been busy with the data plane encapsulation, but as the Geneva is being finalized, so I guess maybe it is the right time to start the standardization of the YANG model. So why to build a base NVO3 YANG first? It is because several encapsulations and VPN technology exist to avoid repetitive works and non-consistent approaches. A common and reusable YANG should be defined. And people can use this base YANG model as a start point for incremental work to fit a specific technology, a data plane, a control plane, and just augment this base YANG model when necessary. So we've been thinking that what is the common and reusable YANG, reusable part for all the NVO3 protocols? The answer is obvious. It is the framework and the architecture which is defined in this NVO3 working group. And I think we should define the YANG model based on this framework and the architecture. So it would be the common and reused part. And during the design of this base YANG model, we have also taken into consideration the EVPN related RFCs and drafts. So I'll be introducing the NVE container in our base YANG model design. And as you can see here, we have a good mapping relationship between the base YANG model and the NVE reference model defined in the NVO3 architecture. And in this blue box, we have defined all the attributes to identify the NVE, and we have also considered the multi-hoping scenarios, any cast gateway, etc. And below that, we have a list of VNI members, because as you can see here in the NVE reference model, below one NVE, we can have multiple VNIs. And then we have the peer. We have a BGP enabler defined here, so which permits an NVE to discover a peer NVE dynamically. Of course, the peer NVE can be pointed statistically, and the enabler is per VNI basis. Thus, for different VNI, we can use different control plane. And then we have the peer NVEs defined here. And we also have flood proxies, which is defined in the RFC 8293. It is known as the multicast service node in this RFC. And we also have the multicast group. And the multicast group is per VNI basis, so we can achieve the tenant isolation. And then we have, it is still in the NVE container. We also have two mapping relationship to indicate which VNIs are used for L2 VPN and which VNI is used for L3 VPN. And it is well aligned with the integrated routing and bridging which is in progress in the BEST working group. And we also have the statistic containers for the statistic usage. For example, the bits received per second, packets, etc., etc. It is defined for VNIs and the VN peers. And the base YANG model has passed the YANG validation. And for next steps, we will continue to check the compliance according to the NVO3 architecture and make sure the terminology is well aligned with other work inside IETF. And comments are always welcome. And finally, if you think the YANG model is in the scope of this working group, and if you think that we are moving in the right direction, please consider adopting this draft. Thank you. Any comments? Thank you.
Okay. So just general comment from me. I think we need to be very clear on the scope of, because we've got another YANG model draft coming up next. We need to be very clear on the scope of the individual YANG models. That one is generic to the overall architecture, and the other one is specific to configuring the parameters of particular encapsulations, right? Yeah.
I hope so.
Yeah.
Okay. Thank you.
Okay. Do you want to? Thank you.
Good morning, everyone. I'm Zan from ZTE. Today, I will do the presentation about the YANG data model for NVO3 protocol. Yes, goals defines the YANG data model for NVO3 configuration and operations. Covers two types of encapsulations, GLIF and Vitalan GPE. In next version, we will add more encapsulation types. Okay, history. Yes, present the draft 10 NVO3 Vitalan YANG for many times. The working group would like to generate YANG model for configuring various elements in the NVO3 architecture. So converts draft 10 NVO3 Vitalan YANG into this draft. Oh, yes, this is NVO3 configurations. Below in the NVO3 containers, it include Vitalan enable, GVE enable, and it also include some parameters with NVO3 instance, and the unicast tunnels, multicast tunnels. For the NVO3 instance, it includes VNI protocol type. We type IPv6. We type IPv4. IPv6, IPv4. Yes, interface and control plane. Right now, it support EVPN and static config. Next is NVO3 operational state. It's similar with the NVO3 config. Okay, next, comments welcome, and welcome to fulfill this work together. Thanks.
I have a couple of comments. First of all, just to make sure that this YANG just cover GNIF and the Vixen GP, right?
Yeah.
Okay. So the second question is, what is the mapping relationship between this YANG model and the NVO3 architecture? Because here I can see the terminology that I've been familiar with. Because, for example, I can see the NVE here, you know.
We will update it. NVE is not. Yes. Oh, sorry. The NVE is not good in this. The architecture will we define the NVO3 instance, and below the NVO3 instance, we defined we type node.
Yes. So what is the relationship between this NVO3 instance to the NVE? So what is the relationship between these two?
Sorry.
So I
Yeah,
think you're trying to say how say it a different way. You're trying to say how do you map between this given VNI instance that you're configuring here and the NVE for that VNI? Where's the mapping? Yeah.
Sorry, there's a mapping?
Well, that's what I'm asking. Is that what you're?
I don't see the relationship. Mapping relationship is. I don't think it is obvious here, because for example, here I see below that NVO3 instance we have the VNI, and I see in the NVE reference model below an NVE we can have multiple VNIs, but here I just see one because you use the VNI, the key of NVO3 instance, you know.
Yes. Thank you. Thanks for your suggestion. We will update it. Maybe it should change it.
So I think it may be a good idea to have the NVE first, and then you can divide the NVE logically. I don't know. I actually I don't get the point here, you know.
I think it's the different implement to achieve the same function, right? Yes, your draft is defined NVE, and below you defined NVI. But my draft, I first defined instance, and below I defined the VType.
Yes, but
yes.
I don't think VType here is equivalent to an NVE. You know?
Yeah.
No, it is not, because NVE, as I said in the NVE reference model, we should have NVE, and below it we have multiple VNIs. But here I can see the relationship is quite a bit inverse.
Maybe we can discuss offline for the details. Okay.
Okay. And a second question, and I think it is quite similar, because here you have the protocol type to indicate, for example, the next protocol of a Geneva or VXLAN GPE.
Yeah.
But so per VNI you have a specific prototype, right?
Sorry.
So you mean, I can see here, first you have the VNI, then you have the protocol type. For example, if we use IPv6 as an example here, and below you also have the unicast tunnel. So you mean that per VNI, per protocol type, you should build a unicast tunnel. Am I understanding it correctly?
Yes. For VPI, first config VI, and below it's the protocol type. It can be Geneva or VXLAN, and then we can bound the unicast tunnel.
But I don't think it is correct, because the motivation to have generic encapsulation, for example, VXLAN or VXLAN GPE or Geneva, is that we are trying to reduce the number of tunnels instead of increasing it. For example, between the same pair of NVE, we can have one tunnel for example, for one tenant, and we can use this tunnel to transport different kind of traffic. For example, we can transport IPv4, IPv6, MPLS, and NSH traffic using the same tunnel. But here you fix it to the finest granularity. I think it is not correct.
Okay, I will think about it, and I will discuss on the mail list.
Okay. Let's take to the mailing list. Thank you.
Yes.
Ignas Bagdonas, the wrong type of the ID for this room, but I do care about manageability. Therefore, I think I have something to say. A question for the chairs. May I just try to hijack the stage for a while and
Sure.
to have a slightly broader discussion? Because what I see happening here is talk about tiny fragments, but I'm not certain whether the working group has the, say, broader view of the manageability.
Yeah, so we did have an operational requirements draft a long time ago. We don't have any kind of, it's kind of not really active. We don't have really any draft apart from our framework at the moment that really scopes out overall what you need to manage in an NVO3 network.
So the problematic aspect that I would see is, first thing, NVO interface is an interface. It's not a special type of interface. Yes, in a spherical router, it might be a special interface, but in a real router, it is not. Therefore, from a manageability point, it should be put into the hierarchy as any other interface and have its own parameters. The transport protocols below and client protocols above, they again should be aligned with the overall manageability of other transport and client protocols. NVO3 is no special. If I want to try to use that for practical purposes in a practical network, if it is radically different than, say, IP or MPLS encapsulated interface, something is just not right. Another aspect, and that's probably broader, and what probably needs to be done is to revisit the use cases draft and try to talk to the user community, what problems they're trying to solve with NVO3 and how they're trying to do that. And this will come as a set of requirements how that should be managed. The fact that you have a young model, it's good, but that is nowhere near enough. It's just a tool, but it needs to fit into the overall management hierarchy somehow.
Thank you.
Okay, thanks. Any other comments? Okay, thanks. So the last slot is for BFD for Geneva.
Hello, everyone. I'm Xiaomi from ZTE. I'm going to present draft shell BFD Geneva. Yesterday, I presented this in BFD working group, and the chair asked me to present here because here is the home for the Geneva. Okay. First, intention of this draft. It specifies the use of BFD in Geneva overlay networks. This draft is similar to another draft that's BFD for VXLAN, which is in ISG processing. So as I know, the major difference between Geneva and VXLAN is that Geneva supports multi-protocol payload and variable length options. This slide demonstrates the Geneva encapsulation. I don't want to repeat all the fields like yesterday in BFD working group because I think in NVO3 you are very familiar with this encapsulation. Okay, this is the first scenario. We defined the IP-UDP BFD encapsulation for Geneva. In this last scenario, Geneva payload can be either Ethernet frames, IP packets, or MPLS packets. So below the Geneva header, the same IP UDP BFD encapsulation defined in RFC 5881 is reused. This is the second scenario. In this scenario, Geneva payload is neither Ethernet frames no IP packets, no MPLS packets. So in this scenario, a new Geneva protocol type is requested to indicate the BFD control message. So we will have a question to ask NVO3 working group. Do we really need this kind of BFD encapsulation? Because I'm not sure about the requirement to use BFD monitoring Geneva tunnel of non-IP service. So do we need to discuss this?
Yeah, so I guess the question is, do we need two separate modes for encapsulation of BFD in here? Can we just rely on the fact that it's IP UDP packet, or do we need effectively a unique protocol type for BFD in the Geneva header? There's kind of precedent for this in MPLS in the past, for example, for you can either run BFD on IP UDP, or you can explicitly identify in the GOCH that you're carrying BFD. But that was specifically for cases when you didn't. That was really for MPLS TP, for example, where you did not rely on IP forwarding at the endpoint. So I think in the case of Geneva, it's an IP underlay. So do we actually have a need for this to uniquely distinguish BFD? Any feedback on this? Has anybody seen this draft or read this draft yet? I think, Greg, do you have any?
I'm co-author.
You're a co-author. Yeah.
Actually, on that note, it's a question for the working group, and in my opinion, it's a broader scope question of OEM in NVO3 and Geneva, because the question is, so how do we encapsulate BFD in this case? So this is a question for this draft, and in general, so how we demultiplex active OEM protocols in NVO protocols and Geneva in particular. So I think that since Geneva specification is stable, ready to be passed to ISG, I think that we're at the time where we can start looking at this question.
Yeah. Okay, any feedback or? Yeah.
Yeah, actually, I do have some basic question first, then maybe we can provide feedback about whether we should include an IP header. Sorry, this is Sami Boutros from VMware. So actually, when you are running BFD here, are you testing the connectivity of the tunnel or per VNI service?
Tunnel.
So what will be the VNI value?
VNI value, yeah. Okay, right.
As being mentioned in the document presentation, there is a lot of similarity with the BFD for VXLAN, and VNI similar interpretation as already. So just a note, you probably know that BFD for VXLAN is waiting for AD review, so it's past BFD working group last call. And we'll follow similar interpretation of VNI in this specification and is VXLAN. So, but obviously, if you have some suggestions,
okay,
welcome.
Yeah, sure. Yeah, I think the other comment is that when we did BFD for MPLS CP and we didn't include an IP header, it was mainly because we didn't have an IP network on which we could be running BFD on with MPLS CP. But I think the case here is different. We already have an IP network.
This is hello.
Yeah. Yeah. The reason, I'm sorry if it's like a two-man show. The reason to question whether to include IP header because it's extra header. And the only purpose of this header is UDP port, so to demultiplex the payload. So think of IPv6 addressing. What an unnecessary overhead we're inflicting just to carry a UDP port. So that's why we're suggesting to consider use of ACH. No, okay, but just think of, BFD is supposed to be lightweight, right? So if we add IPv6, IP UDP headers on top of, if memory serves me, like 40 bytes of BFD, so the header is larger than BFD, right? So the overhead is like 120%, no? So I think that it's a good enough reason to at least to consider it.
Yeah, but I think the same comment applies that the associated channel was added because you are running on a non-IP network. What you are saying is that in here, I understand the overhead part. But
No. Associated channel was not only added because of MPLS-TP. First and foremost, associated channel is just generalization of pseudo-wire VCCV.
Yeah, I understand.
Right? So it's basically taking the clue from technology already existed. Okay? Because basically the same mode is run over pseudo-wires. There is no IP encapsulation needed for the pseudo-wire BFD.
Yeah. I'm saying it was added because of layer 2 only, right? Not layer 3. Meaning associated channel was added for pseudo-wire, for VCCV, because pseudo-wire were carrying layer 2 traffic that could carry IP or non-IP. But here, the case is that we already have an IP network. If you are worried about overhead, anyways, the Geneva header is an overhead, right?
Sami, to my understanding, when you say IP network, you mean underlying network, IP network.
Correct. I think when VCCV was added or associated channel was added for pseudo-wire, we were carrying only layer 2, and layer 2 does not need to carry only layer 3, can carry other protocol other than IP, sorry. So this is why you needed to have BFD running with associated channel, because the network may not have IP and so on, right? But in here, you have an underlay which is IP.
Here, for the overlay point, there maybe no IP.
I think, okay, is this what you are saying? Is that I'm carrying a layer 2 overlay, and now that layer 2 overlay may not be an IP overlay, then should I have an X protocol for BFD similar to the associated channel so I can run BFD on it, right? As a control message only, right? I think, okay, I can buy that argument. That's fine. Thank you.
Thank you.
Tom Herbert. So I'm looking at the Geneva header. There's a control bit or bit that says control packet. In this scenario, what would that be set to? Is this a control packet?
Thank you.
It's already defined in this draft.
No.
It is?
No.
No, for O bit, but for other fields.
It's great question. Thank you.
Okay, what was the answer?
We don't know.
Okay, so let's assume that we do set the control bit. Then my question becomes the protocol type field. What does that mean when the control bit is set?
Another great question. Thank you.
Okay, third part is, this is answered in Go. If the control bit, there's a control bit in Go. If the control bit is set, that protocol type field is now a control type field. It's a completely different numbering space. So what I'm concerned about here is, do you really want to add an ether type for control messages? It seems like a slippery slope. So you might want to consider something like that.
Okay. I'm just want to check with the chair. Are we overusing our time, or it's okay?
I think we've got 5 minutes.
Okay, I'll try to brief. Thank you for great questions, because I was waiting for somebody to say, okay, so how do we do OEM and what this bit, how it's interpreted and everything. For Geneva, again, not for Geneva, but I have a little bit different analogy and point to what has been done in SFC and SH. So SFC and SH does have OBIT, which in 8300 RFC was defined as identifying OEM packet. There is draft IETF SFC multi-layer OEM, which we name as SFC active OEM draft. It extends this definition, so I don't want to repeat it off the top of my head, so just take a look there. And we have defined with the working group together how OBIT with the protocol field identify combinations of OEM, whether in header extensions, because they can have in NSH fixed length extension or variable length extension header, and OEM in a payload. So it defines the situation that OEM information, data or commands are in a header part, or in a payload part, or there is none OEM at all. Okay, and that actually, there was a discussion, I think, in Bangkok, and Adrian provided case that led us to point to situation that has to be interpreted as erroneous extension situation. That OBIT is not said, but next protocol field one of OEM, so that has to be interpreted as erroneous. I will encourage you to look at this. I made presentation at RTGVG group, so there is a draft that I'm kind of keeping alive until I think that everybody who's supposed to read it and listen got to me with questions and said, well, let's talk about it. It's overlay OEM identification. And I know what GUI is doing. I'm not completely agree with that, because there is not all OEM goes to the control plane. In particular, BFD things are done usually in the hardware. So thus changing two namespaces might be unnecessary burden on the hardware support implementation. But I'm open to discuss it.
So one comment. So you made an important point. There are two flavors of this. One is the payload is the control packet. And two, we want to attach control information. So it's not about OEM or this. It's about how do you deal with these two flavors? I have arbitrary control information to attach, or I have specific. In this case, it looks like the payload is the control data, which means
no. This payload is what's supposed to be processed in the hardware.
So is the payload contain an IP packet?
That's another thing that we just discussed.
It's not. What I mean is it being attached to a user IP packet?
No.
Okay, so then I consider that a control packet. It's not, okay, I'm not concerned about data versus, or hardware versus not hardware. On the wire, what does this packet look like? If I say this is protocol type 800 and that those bits are some kind of control information, that's not IPv6. So the protocol type and the control bit and the payload have to work together so that it's unambiguous what that the Geneve payload contains. And since we know that transit devices are going to try to parse this, it has to be unambiguous for them, not just the endpoints.
Actually,
again, I just want to close this discussion, and I think that
no, actually, one last comment. So actually, if you are talking about ACH here and so on, did you consider putting GASH and an MPLS label, like the GAL label, and saying this is an MPLS packet? Why not? Why not? I mean, like you are using the same approach. The way we did it in MPLS TP is that you put a GAL and a GASH, and
let me answer the question. So I was busy mumbling, oh, good Lord, don't do that. Okay, so this discussion needs to go up a level. This is David Black. We need to talk about why we're doing BFD in the first place. What is the thing on the far side whose liveness and ability to talk to us we'd like to establish? And I believe what we're going after here is the chunk of the NVE that knows how to decap, Geneve. So the hardware is busy being referred to is the hardware that chews on the Geneve header. The encap shown here is an effective way to do that, because what essentially it says is the hardware chews on the Geneve header. Something in there says this is BFD, and the BFD payload comes next. And now you have BFD solving the problem you wanted to solve. Is the NVE capable of chewing on Geneve, or did something break before it opened up that header?
But actually, I still didn't get it. So you want BFD or you don't want BFD?
No. I want the BFD header to be as close to the thing whose liveness I'm testing. The more headers you add in the middle, the more ways there are to break BFD without breaking the forwarding engine I care about, or the other way around. The further away I move BFD from the chunk of hardware's liveness I care about, the more opportunities there are for BFD and the hardware to not tell me the same thing.
Yeah, Zagal is only 4 bytes, right? So
No. But it's 4 bytes you don't need. Code up in, as shown here, find some way to code in the Geneve header. This is BFD. Then the hardware that processes the Geneve header grabs BFD and says, yes, I'm here.
And that's possible just to use the next protocol, allocate BFD next protocol, and be done with it.
yeah,
Particularly here, where we're trying to deal with bizarre outbreaks.
I mean, it's already defined with ACH having BFD with no IP header, and you want to use an ACH approach. So I didn't understand the argument why not use the ACH approach as it's defined already.
Okay, I think that what we can agree on that this is a separate topic for discussion because it's broader than just BFD.
Yeah, I think somewhere, just to conclude, I think somewhere where we need to describe how more comprehensively how the OBID is used and how that should be interpreted in Geneve. I mean, in other technologies like CIDR, we had, you define an exception mechanism, whether that's 0001B on a header or it's router alert. I mean, to me, my interpretation of the OBID here is it's an exception mechanism that says this is a control channel message, and no more than that, right? But what the structure of that control channel is, whether it's something with an ACH, whether it's an IP channel, is undefined at the moment.
Yeah, but I think what we defined was that you had the MPLS label and you had the ACH.
Right.
And that's under the small label inside, and it's expected to see Ethernet from there to packet.
Yeah.
Which is similar to what's happening here.
But you have some additional context in that case to know what you're looking for. Here, you don't have that additional control plane context. Yeah.
So you already defined a special label, which is an MPLS label. So next one, we can be MPLS and we have done it. Anyway.
Okay. All right. I think we're out of time. Thank you very much, and see you in Montreal.